So for method 2, the whole goal was to have two entities and tie them into one component. So here I have my ALU1. I have two inputs, A and B, which are both 4 bits. I have a selector, select, which is 1 bit, and I have an output of X, which is 4 bits. So in my ALU1, I choose two operations. I choose if 0 is selected, the output would be A plus B. If 1 is selected, the output would be A and B. Here for my ALU2, I do something similar for my entity and the architecture of my behavior. If I select a 0 this time, I will OR A and B, and if I select 1, then I will XOR A and B. Here in my top level is where I tie both entities into a component. Here you can see ALU1, ALU2. I create signals, create my port map for my ALU1 and my port map for my ALU2, which is how you construct the component. And in my process, here, if select 1 is 1 or select 1 is 0, I will output B. And if my select 2 is 1 or my select 2 is 0, then I will output A. So here is my test bench. I construct a test bench, and this time I use my top level as my component. Create some signals, set them to 0. The simulation, when it starts, is going to wait for 100 nanoseconds. And then my input A is going to be 0110, which is 6. And my input B is going to be 0100, which is 4. And I have all the different options of select 1 and select 2 that I can do. So here in my simulation, like stated before, in the first 100 nanoseconds is going to wait, so it's going to output a 0000. So when I force select 1 to be 0, I'm going to AND 0110 and 0100 to get 0100. If I force select 2 to equal 0, then I'm going to XOR my input A and my input B. So when I XOR 0100 and 0100, I get 0010. When I force select 1 to be 1, then this time I'm going to add 0110 and 0100. And that's going to give me 6 plus 4, which is 10. And 10 in binary is 1010. And then when I force select 2 to be 1, then I'm going to OR my input A and B. So 0110 and 0100, when I OR it, it's going to be 0110. And that is how you simulate method 2.